All right, we starting at number 1?
Yeah.
Okay. So, unfortunately, the way they've labeled that table, that's a bad way to label it. Where does that f of x go? Goes above the y.
Okay.
In other words, f of x is the same as y. Okay. So, if our function is 3 to the x power, what is y, or f of x, when x is minus 2?
-9.
Remember, negative exponents do not mean negative numbers. We have 3 to the minus 2, correct?
Yeah.
Okay, first step, translate that to a positive exponent. What is it?
3 to the 2.
No, it's 1 over 3 to the 2.
Oh,
First of all, it can't be 3 to the 2, because that would be saying 3 to the minus 2 is the same as 3 to the plus 2. So that can't possibly be right. So when you see a negative exponent, it merely means put it on the other side of the fraction bar.
okay.
So what's the answer?
1 over 9.
Correct. Keep going. Minus 1.
Would that just be 1?
What would it be? 3 to the minus 1. What's the first step?
Oh, put it,
Take away
1,
the negative exponent. How do you get rid of the negative exponent?
move it down.
Okay, so what is it?
So 1 over 3 to the 1?
Correct, which is 1/3.
Oh, okay.
Now, what about when x is 0?
Would it just be 3?
Now, remember what any number to the 0 power is. This is a rule in algebra that you just got to memorize and always know. It doesn't matter the size of the number. If you take it to the 0 power, you get 1.
Okay.
3 to the 0 power is 1. And tell me the other 3.
And then 3, 9, 27.
All right. Make a table of values for f inverse of x. Well, what's true about inverse functions? There's one really big thing about inverse functions. You swap the domain and the range. So I don't have to do any math. I don't have to figure out what the inverse is. So all I'm going to do is swap those two columns.
Okay.
And that truly is a really big part of inverses, is knowing that. Now, on this question right there, what does that draw a line of symmetry and determine its equation. All right. I think that's what they want there. What else is true about inverses? Graphic. In other words, if I have an inverse function like that, or excuse me, if I have a function like that, remember what the inverse is. It is. This is true with all inverses, no matter what level of math you are at. They are reflections over that line.
Okay.
So if I want to draw the inverse of my original function in red, I'm going to reflect it over that line. This is going to be my inverse.
Yeah.
By definition. Okay, I didn't even say what that function was, but that's my function. That's my inverse. The line of symmetry, and determine its equation. What's the equation? First of all, look at the green function and the red function. You see where the blue line is the line of symmetry?
0?
No. First of all, answer my question. Look at this graph over here.
Yeah.
The red line and the green line are inverses of one another. Okay? That means they are mirror reflections. About what line? What's the color of the line that they are reflections about?
Blue.
What's the equation of that line? Y equal x.
Okay.
That thing has a slope of 1. And it goes through this point right here. In other words, its y-intercept is 0. So it's y equal 1x. And that is true no matter what the equation is. Or no matter what that is. It does not matter what the function is. The inverse of that function is always going to be a mirror image about the line y equal x. It's not a mirror image of the x-axis or the y-axis or the origin. It's a mirror, it's a reflection about that blue line.
Okay.
Okay? All right, so let's do part 3. So first of all, let's graph the function. That's pretty easy to graph. Remember, these exponential functions always go through that point, and then they turn up fast, like that.
Okay.
So there's my original function. That's f of x equals 3 to the x power. Okay? And we don't know what its inverse is yet. We never figured it out, and we don't need to. They never asked us what the inverse function was. So all they said was graph it. Well, I can graph the mirror image of that red graph pretty easy.
Yeah.
Something like that.
Okay.
I may not be precisely on, but we've answered all 3 questions. In other words, we've graphed the function. That's the red line. We've made a table. And we've graphed the inverse function. We've determined the equation not of the inverse function, but of the line of symmetry. So we did that part. The only part we really didn't do is the equation of the inverse. So let's review that. Let's go back to the beginning. Y equals 3 to the x power. How do you find the inverse function for that? What are the 2 steps you have to do? First step, you swap the variables.
Okay.
Always the same thing.
All right.
So swap the variables. Excuse me. If I could swap the variables, that'd be good. And the second step is you solve for y. Well, this isn't so easy, solving that for y. But the way you do it is using logs. You've had logs, right?
Yeah.
Okay. So I would take, well, I could take there's a couple of answers that are correct. I'm going to take the log base 3 of both sides. So there's the log base 3 of the left side. I'm going to take the log base 3 of the right side. Now the key is what happens to the right side? What is the log base 3 of 3 to the y power equal to?
Would you log 27y?
Equal to y. In other words, whenever you see this, when these two numbers are the same, the answer is always that.
Okay.
Now, on the left side, there's my answer, log base 3 of x. And I believe I've got these out of order. That y equal x goes over here. And the equation they're looking for is f inverse of x. That's our new y, is f inverse. It's not the same as this y. Remember, I swapped the variables. So it's log base 3 of x. Okay?
Okay.
That's that first question. There was a lot in that first question. There was a ton. What did it take us? It took us 15 minutes to do that first question. And there really was a lot of key information in that. All right. Do number 2. Well, the only thing we have to do here is graph it and graph the inverse. And we can graph the inverse in a couple of ways. The best way is to figure out what the inverse is. So let's do that, first of all. Well, first of all, let's graph it. We know we have to graph it. How do we graph it? A.
Would you go
Where do we start?
at 3x?
Nope. You're looking at y equal mx plus b. How do you graph that? Where do you start?
Oh,
You always start at the y-intercept, which is b.
minus 4?
Now what?
And then,
Apply the slope to get the second point. Remember, these are all straight lines. That is a linear format. That's linear. So it's all I need is 2 points. So come up with a second point, I'll connect the dots, and we'll have our graph. In order to come up with the second point, you got to use the slope. What's 3 mean?
up 3?
And
Over 1?
over which way?
Right.
That gives you a positive slope, which is what we have. Okay. So that's our first line. Now, I don't really want to draw y equal x on there and reflect that line. I'm not real good at reflecting. So let's come up with the equation of the inverse. So what's my first step?
Flip the
flip the variables. But notice this does not start out in y. So really the first step is to call f of x y. We know y and f of x are the same thing.
Okay.
Now you can apply your two steps. What are they?
So flip,
Not flip, swap.
swap x and y.
So tell me the next line.
X equals 3y minus 4.
Now what?
Now do you apply logs?
Nope. Now we solve for y. These inverses are really easy. You swap the variables and you solve for y. That's it. That's really the only two things you have to memorize. You swap the variables and you solve for y. So let's solve this second equation for y. And whatever we get, that's the inverse. Solve that, starting from there.
Would you...
You want the final line to be y equals. How do you get it to be that? You got to get rid of everything else that's over there. We got a minus 4, we got a 3. Well, I'm not going to get y equals until I get rid of all of those. Which one do I get rid of first?
4, so add 4.
How do I get rid of the 3?
Divide it by 3.
So here's our inverse. Right there. And instead of calling it y, it's not really appropriate to call it y because it's not that y. It's the inverse of x. Okay. Now, if I wanted to write that a little different so it's a little easier to graph, I would write it as this. So there's the inverse function. Now tell me how to graph that. Where do I start?
You would...
Where do I start on this one up here?
At B.
Okay. So always do it the same. Math is all about memorizing methods. It's not about memorizing formulas. It's about memorizing methods. So we figured out how to do this, how to graph an equation that's in that format. So what's B?
4 over 3.
Okay, that's about 1 1/3. Where's my second point go?
Why wouldn't you do up 4 over 3?
Because it's not the slope.
Oh.
It depends. The B is the y-intercept. The M is the slope. What's the slope in this inverse function?
Up 1 over 3.
Good. So up 1 over 3 puts it about right there. Connect those two. And I've done exactly as they asked. I've graphed it. I've put it in a different color. I've sketched the inverse. We're done. Now, it is worth noting. Notice the blue and the red lines are reflections about that green line. Y equal x. All three of them should go through that point right there. But that's all it is a reflection about that line. Okay? All right, let's do B. First step, let's graph it.
Okay.
Let's graph that function. So how do I graph that function? They said graph it using transformations. Well, what's the parent function?
X plus 3 cubed.
No, it's x cubed.
Okay.
Y equal x cubed. Okay. If I were going to graph y equal x cubed, it looks something like that.
Yeah.
How is this different? In other words, looking at transformations, how is x plus 3 cubed different than x cubed?
Because it has, I'm not sure.
Well, you have to know your transformations. There's 6 different transformations, okay? This is a horizontal shift to the left by 3 units. So instead of this graph here that I've graphed, I'm going to graph the exact same graph, only I'm going to shift it to the left. So instead of going through the origin, it's going to go through that point right there. It's going to have exactly the same shape. And everything looks exactly the same on it, except this vital point where you can see there's a big difference in the shape of the graph there. That is now at minus 3, 0 instead of 0, 0.
Okay.
So let's find the inverse.
Okay.
Tell me how to do it.
So first you're going to change f of x to y equals. So y equals x plus 3 cubed. And then you're going to switch the x and the y. So x equals comma y plus 3 cubed.
Okay.
And then we have to get y on its own.
We're solving for y.
So first you would cube root it
Good.
on both sides, and then subtract 3.
Good. And that 3 is outside the parentheses. And so, again, let's change this y back to f inverse of x. So the inverse function, written like that, is, I'm going to write it like this, x to the 1/3 minus 3. To me, it's a little cleaner using exponential fractional exponents rather than cube root signs that have a 3 in it. Okay. Now, this one, a little more difficult to graph. Notice that it is the graph of the cube root of x all shifted down by 3. So instead of graphing this function, they say sketch the inverse. So we don't have to do a great job. So instead of figuring out how to graph that, I always have trouble with this function, x to the 1/3. I don't know why, I just do. It's not something that my brain sees well in graphing it. So this time I'm going to graph the line y equal x, and I know that the inverse is going to be a perfect reflection of that. Well, what does that mean? That means if I go up and that point there is going to be right there, this point here is going to be right about there, and so I'll just graph a bunch of points. You notice what I'm doing here? I'm measuring this distance is exactly the same as that distance. So that's how I'm reflecting it. Now I'm going to connect those dots. And there is a pretty darn good sketch of the inverse. And I didn't know, if you look at that inverse function, you will notice that it is x to the 1/3 shifted down by 3 units. In other words, if I were to graph just x to the 1/3, it would look something like this. Go right through the origin. So that's x to the 1/3. And what we're looking at is this graph shifted down by 3 units, which is exactly what it should be. Okay?
Okay.
All right, let's go to the next one. All right, these are, okay, just find the inverses.
Okay.
First one.
Y equals 2x plus 5.
Yeah, just read each line to me. That's a good way to do it.
X equals 2y plus 5. And then subtract 5. And then divide by 2. So that gets you...
And instead of calling it y, we're going to call it f inverse of x. Notice
Okay.
why we do that. We don't want to call it y. It is not that y. That y is the original function, f of x. Well, this is the inverse function. So we're going to call it f inverse of x. We're not going to call it y. So in a way, you can almost, let's maybe examine this. It might be a better way to do it. Let's not call that y. Let's merely swap the variables. So, let's see. So x equals 2, and now we're going to call that f inverse of x plus 5. So you can kind of see that we really didn't swap the variables. We swapped the variables and changed it to inverse.
Yeah.
And now if you solve that, you get the proper answer, and it's got the proper name already attached, and we skipped a couple of steps. So this is not a bad way to do it, where you don't go through changing that to a y. You just leave it, but when you swap sides, I don't know, it kind of makes more sense with the y, don't you think?
Yeah.
Yeah, losing those 2 steps doesn't help, but it does solve one problem, which is making sure that your final answer is called that. You don't want your final answer to be called y. I bet you'd lose a point or 2 for that.
Yeah.
In other words, if you just call it y, swap the variables, solve for y, put it as down as your answer, I think you'd lose a point. So in B, let's do it, only let's make sure we call it y. And then when we get done, let's make sure we call y g to the minus 1 of x.
Okay.
Okay, so read the lines.
So x is equal to,
You're going to do it this way over here?
yeah,
Okay.
is equal to y minus 3 squared plus 7. And then,
Okay, so actually you're doing it the first way. You just omitted the step where you said y equals x minus 3 squared plus 7. In other words, you're doing it the first way. You're not doing it this way over here. You're not going to call that g to the minus 1 of x, which is fine. Okay, so what's the next line? So you swap the variables.
Yeah.
Now
So
solve.
now, you subtract 7, square root it, and add 3. So you get square root of 2, y plus 3
Hold on.
minus
Hold on.
7.
Hold on. You're getting confused because there's so many here. Let me write it out step by step. You're doing it right. You're just saying it wrong.
Okay.
First step, swap the variables. So now we have this. Next step, solve for y. Tell me what you got. First step,
Subtract 7.
next step.
Square root it.
I don't need the 2, as long as I write it like that. Okay, next step.
Add 3.
So our answer is x minus 7, and the 3 is outside the radical sign. We weren't taking the square root of 3. And instead of y, we're going to call that g inverse of x. That is the sequence you want to go through. Those 4 steps right there on every one of these. If you're going to introduce y, well then start out that as your first step. And then when you get to the end, that y is not the same y. This y here is the inverse. And the inverse function is g to the minus 1 of x. And all we're doing is trying to find the inverses here. These are actually pretty easy. You know what? Here's a problem. With the previous problem. Let me show you what it is. I don't even know how important this is, but it's important in math. That's all I got to show it to you. If I said y equals x squared, that's this parabola. Okay?
Okay.
And if I say find the inverse, well, then it's x equal y squared, which means y equals the square root of x, correct?
Yeah.
Wrong. Y equals plus or minus the square root of x. So the true inverse of this thing is, and I'll draw it in a different color. Remember, I'm going to reflect it. That's what the inverse looks like. And that is that. Notice the top part is your square root function, the plus side of it. Bottom part is the negative square root function. And there's only one problem with this. That's not a function. That is not a function. It does not pass the vertical line test. Okay? So the real answer up here was plus or minus that plus 3. There's my proper answer given the question they asked. They didn't restrict x to the positive side of the spectrum. If they would have, then its inverse would have been a function. In other words, if they would have restricted x to just this part right there, then I can take the inverse of that and I have a function. It's this part right there. That is a function. But since they didn't restrict any of it, then we have to do the pure mathematics of it. And the pure mathematics means it's plus or minus the square root. Whenever you solve an equation by taking the square root of both sides, this is a good thing to memorize. When you solve an equation by taking the square root of both sides, your answer always begins with the answer plus and minus. Example, x squared equals 4. For me to solve that, I've got to take the square root of both sides, right?
Yeah.
So x equals, my answer has to start with the words plus or minus. And the square root of 4 is 2. So that's the answer. And it's no different when you're doing any math, whether you're looking for inverses or not. Now, they didn't say find the inverse function. They just said find the inverse of the following functions. Well, that's a function, and that's a function. So the original functions are functions. They do pass the vertical line test. This parabola is a function, okay? But you can't take inverses of all functions and necessarily have them be functions. And this is a case where it's not. You can come up with the inverse, and we did, but it is not a function, which is okay. They didn't say come up with the inverse function. They just said find the inverse. So if we're going to find the inverse, we need that plus or minus right there. Okay, so I wanted to cover that because that's important, very. Not sure if they necessarily were wanting you guys to cover that or not. It's going to come up again on D. Now, it doesn't come up on C because we have cube root. Plus, we're starting with cube root. So the solution here is going to be to cube both sides, right?
Yeah.
So whatever we come up with will be a function. Now over here, same thing. We're starting, well, maybe not the same thing. Let's do C first. So go through the steps, calculate the inverse.
So flip. So make h of x, x, and then
Oh,
2.
make h of x y.
Oh, yeah.
I noticed you did that on the other one too. So that's an important first step. It is merely to call h of x y. That's all you're doing. Everything else exactly the same.
Okay.
Now, there's 2 more steps. What's the next step?
Swap y and x.
That's really easy to do. Next step.
So now,
Do you get rid of the cube root or do you get rid of the 5?
the 5.
Exactly. Because the 5 isn't being cube rooted. It's completely away from all this other stuff in the numerator. So I'm going to multiply both sides by 5 and simplify it tremendously by just doing that. Now what?
Now you cube root it.
Not you cube rooted. It's already being cube rooting.
Oh, cube it.
So we're going to cube it. So we're going to take that to the 3rd power. We're going to take that to the 3rd power. What's the left become?
2y minus 4.
The left. What's 5x cubed?
Do you multiply it?
No, you cube it.
Oh,
5 cubed.
125x.
Well, you got to cube the x also. Notice both the 5x, both the 5 and the x are inside those parentheses. Okay, so you got to cube each one of them. That's the same as 5 cubed times x cubed. Now, when I cube the right, it's a lot simpler. It just becomes whatever was in the radical sign. Okay, now keep going.
Then you add 4. And then divide by 2.
And finally,
you get
you got to call that not y, but what?
h inverse x.
Yes. So those are really the 4 steps you want to do on every one of these problems. Or 5 steps, whatever that was. Okay. And we didn't deal with any of that plus and minus stuff on this problem. First of all, it's not true with cubes. If you take the cube root of both sides, you do not begin your answer with plus and minus. It's either minus or plus, one or the other. It's only when you take square roots or even roots. If I took a 4th root, I would have to begin my answer with the words plus and minus. So, let's do D. Go through each step.
Okay. So you change f of x to y, and you get 4, y equals 4, parentheses, x plus 5 squared minus 9.
Okay.
And then swap the x and the y to get x equals 4, y plus 5 squared minus 9.
Okay.
So first you're going to add 9.
What are you going to do after that?
Divide it by 4.
So that's equal to this. Now what?
You're going to cube
No?
it. Cube root.
What power is that?
Squared?
So what are we going to do?
Oh, square root. Oh.
Okay. So what's the next line? Remember, when you solve an equation by taking the square root of both sides, you begin your answer how?
Plus minus.
Okay. So plus minus is over there. Over on the right's the easy part. Y plus 5. Everything here goes inside of there. And finally, you're going to subtract 5 from both sides.
Yep.
That's going to give you this. And actually not finally. Finally, you got to turn it back into what?
F inverse of x.
Right. In other words, if our first function was f of x, this is f inverse of x. And this is the answer with the plus or minus. And whenever you have a plus or minus like that, this is also not a function. This would not pass the vertical line test. Nonetheless, it's still the answer. Because they didn't ask for functions. They asked for inverses. All right, we're done with this page. Got another page?
Yeah, I can verbalize it, I think.
Okay. Just use a lot of this white space here, and I'll use this page here.
Actually, I'll just send it to you.
Okay. Pretty easy in this day and age of technology to take a picture and email it. It's unbelievable.
Yeah.
It's the only thing that allows me to tutor online. You couldn't tutor online 10 years ago.
Yeah.
because nobody had this capability here. I mean, they were just getting it, but tell me when it says file sent. I got it. Okay. Don't have a lot of time. There's a lot of log problems here.
Could we work on 3A?
Uh-huh. Well, now those aren't log problems, they're composite problems. And that's fine. Be happy to work on 3. And in fact, because we only have 10, 12 minutes left, probably good to stay on the same subject.
Okay.
Okay. Now, if I give you two functions, f of x and g of x, and I say to you, are those inverses of one another? Well, you got a couple of choices. You could solve for the inverse of f of x and see if it's equal to g of x. If it is, they're inverses. So that's one way. Can you read the rest of the top of that sentence that got cut off?
If they are inverses, explain how you know they are inverses.
Okay. That means we got to do it the second way. In order to explain why g of x is an inverse of f of x, there's something I have to prove to be true. And that's this. This is the composite function. Sometimes this is called fog, but mathematically I would say this is called f of g of x. Okay? Now, if f of x and g of x are inverses, that has to be x, equal to x. So that's how you prove two functions are inverses of one another. And this also has to be true. G of f of x has to also be x. So normally we only have to prove one of them. So we won't go to the trouble to prove both. Okay? Now, let's talk about what that means. If I said to you, what is f of 2? What would you do? Here's the f function. What's f of 2?
Would you put 2 in the equation?
Where?
For x.
Correct. In other words, it's 2 plus 4 cubed plus 10. So the rule is that whatever is in the parentheses, you plug in for x. If I just said f of 3, then I plug in 3 there. You with me?
Yeah.
Okay. That is most important, that you understand that. Now, f of g of x. Well, what do I put in the parentheses?
You put both equations.
No, you put just the g of x.
Oh, just g of x.
Yeah, that's g of x right there. So instead of writing g of x, I'm going to write that equation. It's the cube root of x minus 10 minus 4. That's what g of x is. Okay? Now, just like when I said, what is f of 2? You plugged in 2 for that. Well, what are you going to plug in for x now? Everything that's in the parentheses.
Okay.
So I go up to here. There's my f of x. and I plug it into the f function, not the g function. I'm done with the g function. Once I knew what g of x was and I plugged it into the parentheses, I'm done with it. But I have to take that entire thing, all of it, no matter how complicated it is, and plug it in wherever we see that. Well, I see it right at the beginning, so let's start by doing that. Cube root of x minus 10 minus 4. There's the x right there. Okay? Now, I have to add 4 to that. Add 4 right there. I got to cube the whole thing, and I have to add 10. The whole question is, does that thing come out to equal x? Well, tell me how to solve that. It's the first thing to do.
Add the -4 and +4 together, so they eliminate each other.
Okay, now you got the cube root of this, all of it cubed.
The cube root would go away then, as well as the cubed.
Right, so I'm left with that, and then I still have my plus 10. Guess what? That's equal to x.
All right.
That means g of x is the inverse of f of x and vice versa. It's also correct to say that f of x is the inverse of g of x. Once you prove two functions are inverses of one another, then you can go both ways on it. And this is definitely the way they wanted you to do it, as opposed to solving for the inverse, coming up with that and saying they're inverses of one another. That's not proof. To prove something is an inverse of something else, you have to pass this test. F of g of x is equal to x. Let's at least set this one up. May not have full time to solve it totally. What's the rule?
F of g of x
has to equal
x.
If I can prove that to be true, then these two are inverses of one another. So what's the next thing I want to write? F of what?
F of square root of x minus 5 minus 4. That's it.
Okay, now tell me what that's equal to. In other words, now we're done with the g of x function. Now we're dealing entirely with the f of x function.
Equal to parentheses square root of x minus 5 minus 4, and then plus 4 parentheses squared minus 5.
Perfect. Now simplify that whole thing.
Get rid of the minus 4 and plus 4. They cancel out. And then the cube root and squared cancel.
The square root and squared.
Yeah, square root.
X minus 5 minus 5.
Yeah.
That's not it. That's x minus 10. So those are not inverses of one another. That is not the inverse of that. Not unless I made a mistake. No, I did make a mistake. No, I didn't. No, it's minus 4. There's that. And then it's plus 4. There's that. And then it's minus 5. And that certainly comes down to x minus 5. I still have the other minus 5, so it is x minus 10. So just because you see same numbers, don't automatically assume that they're going to cancel one another.
Okay.
In other words, in this question, they were both minus 5, so it did not come down to x. So no, they are not inverses of one another.
So after you get no, do you have to keep going on the problem?
No. The question said, use composition to determine if they're inverses. Well, we did, and they weren't.
So would you just write no, they are not inverses?
Yep. On A, yes, they are. But the thing that's really going to tell it is when you get down to the bottom of B, and you've got f of g of x is equal to x minus 10. Now you can put a big NO below that.
Okay.
Okay, in other words, you're going to get down to the bottom here. Let me just add that last step. What you want to do to make it perfectly clear to the teacher is that this is equal to x minus 10. That's a big NO. Those are your last two lines. For B.
Okay.
Okay? Lachlan, I will let you go and talk to you next time.
All right. Thank you.
All right.